integrating the code that we will be designing for data storage and communication, along with the code that is provided by Intersys for communication back to their SCADA home. The SCADA pack is enabled with data storage and wireless communication back to a SCADA host, and also a Bluetooth module that we will be using to connect to a laptop GUI via wireless Bluetooth communication. I'd like to take a moment now to describe our work breakdown structure. As you can see, our project, JAP2, is broken into 6 different phases: research, hardware, software, procurement, testing, and finalization. Our research phase includes researching various protocols that will be used with our system, including, but not limited to, Modbus and Bluetooth. We'll be researching the various measurement devices used in our project. We will also be researching a variable speed drive controller, the specifications of the SCADA pack itself. We will be researching oil production methods, placement of these sensors in our system, and the overall system perspective itself. The hardware aspect of this project will include schematic design on a breadboard level, a simulation level, multi-sim, design level, and multi-board. And also we will be developing sensor input circuits for our project. This will all include multiple revisions of the PCB layout, and our final prototype will include an enclosure with a fully functional prototype. Our software phase of our project will include analyzing the sensor inputs, processing signals for Bluetooth and Modbus communication, data acquisition and storage of data obtained from the sensors, outputs to the variable speed drive and the emergency shut-off system, along with data storage in the SCADA pack, and also a user interface at the HMI level and the graphical user interface level on the technician's laptop. Our procurement phase represents everything that we will be acquiring during the phase of our project. This includes all components, such as the PIC24 microcontroller, all the sensors, and the housing for our unit. We'll also be acquiring various equipment, such as oscilloscopes and measuring devices for our project. We'll be acquiring the previously developed SIGCOMM unit, the SCADA pack, the programming environment for the PIC microcontroller and the SCADA pack. We will also be obtaining the motor that is going to be used to drive the system. We'll also be acquiring funding from the various stakeholders who are interested in our project. The testing portion of our project is arguably one of the most important phases. In this phase, we will be building a test plan to test the breadboard level circuit along with the PCB level circuits. We will be testing each of the individual components, such as the sensors, for functionality and calibration offsets. We will also be testing the software thoroughly for user interface, ease of use, data storage, and the entire closed-loop control system. We will also be testing our final prototype to make sure it meets all specified requirements for Intersys. Our finalization phase includes fully functional working prototype, communication with the SCADA pack via Modbus, communication with the laptop GUI via Bluetooth, and a fully functional closed-loop control system. Our documentation will include the user manual, schematics, source code, test plan, and a final report delivered to our customer. Now I'd like to hand the presentation off to Brian Rowe.
Thank you, Alex. Based on what you just saw in our work breakdown structure, there is a lot of work that is going into this project. So we've gone ahead and developed some milestones that we will reach during the course of our project. These are events that will occur during our project that have value to us as a company, as points in time where we complete a major event in the design and implementation of our prototype. Among these are the selection of components for JAP2, the design and development of a PCB board, which includes getting approval of our schematic design and PCB layout. Also, the design of our user interfaces, including the technician's laptop and HMI. We'll also design the communication software between our prototype and the SCADA pack, and between the SCADA pack and via Bluetooth to the technician's laptop. The testing of our prototype will also be a major event for us to show that our design does actually work, as well as the design of the motor control system and demonstration of all our programming source code. And finally, the working prototype will be a major milestone in our project. Now, this is a general overview of our timeline for these milestones. As you can see, we will be selecting the components and begin designing and have the design for our initial PCB design within the first 2 weeks of the project, and we will order components at the end of the second week. We expect to have initial test results on our preliminary board by the beginning of October, and we'll be able to finally demonstrate the functionality of our code as with the entire system the beginning of November. We've also created a list of deliverables that we will include documentation and presentations that we will be giving to our customer and our advisor. And these include the pseudocode for all of the programming we will do, as well as flowcharts for how our user interfaces will flow. Some of the demonstrations we will give are the demonstration of the software, as well as the final demonstration of our fully functional prototype. As far as documentation goes, we will be presenting a bill of materials for each revision of our board as we go along throughout the project. And we will, at completion, we will present the customer with a user manual for the system, as well as all of our test reports and final documentation overviewing and going into detail of the project. Finally, we will present our customer with a fully functional working prototype. We've created a timeline for our deliverables as well, and this isn't a complete timeline, it's just a general overview. We expect to have a test plan created within the first week of our project so that we can design from our test plan our preliminary test report for our first board will be at the end of September, and we will be able to demonstrate our code, as I said, for our milestones. We'll have a demonstration for that at the beginning of November, and finally our final documentation and project will be completed at the end of November. We've also created a breakdown of our resources for this project that we are using to estimate the total cost of this project. We've separated this into multiple segments. First is the hardware segment, which includes the cost for boards, the housing, all the sensors we will use, as well as connectivity cables and other components that we will use in the system. We've also included the price for the SCADA package that we will be using in this project, and this section comes out to just over $900. For software, this price includes professional editions of such programs as LabVIEW, Multisim, Multiboard, as well as the SCADA pack programming environments. We've also included the price for 2 computers that we will use to design, test, and complete other aspects of the project, such as documentation and correspondence. This section comes out to just over $10,000. For our equipment section, this includes the price of testing equipment such as oscilloscopes, multimeters, function generators and other